So we're going to talk about the real number system. Okay. Now, I just want to test your knowledge. You can unmute yourself whenever you feel like and let me know what you think. Okay, first thing I'm going to ask is, do we know what this N, N-O, Z, Q, Q with a little apostrophe, and R stand for? Anybody want to venture what any of these stand for? Any of them. You can pick whichever one you know best, and you can pop it in the chat, and I will put it underneath the correct thing. Oh, I saw a hand there, and then the hand disappeared. What happened? Remember, guys, you can just unmute. You can just unmute and take it away. Okay. Anybody? Okay. I will give you guys a hint. This one. Oh, somebody's unmuted. Who is it? Tandolwetu, is that you?
Yes, ma'am.
All right. Hi, Tandolwetu. Oh, no, Lutando's having trouble hearing me. Yes, sir. Okay, I'm just going to quickly message Nolutandos. Okay, but you can take it away. Go ahead and tell us, Tandolwetu, what do you think?
Okay, ma'am. I think N stands for natural numbers.
Beautiful,
NO stands for
100%.
NO stands for
Stands
whole
for?
numbers.
That's it. Keep going.
The Z stands for integers.
Excellent. Integers.
Q
And
stands
Q?
for rational numbers.
That's it. Rational numbers.
And then
And
the
Q
other
with the
one,
little
irrational numbers.
That's it. Irrational. And don't forget the very last one. And the R stands for? You don't know the last one.
I'm not so sure, ma'am.
Okay, I'll give you another hint. It starts with an R. Think about it.
Oh, real numbers.
That's it. Beautiful. Well done. Good. These are all the numbers that we need to know. Okay. Now, Tandolwetu, I feel like, you've just won the biggest prize here because you've helped everybody when they didn't know what was happening. And now you've given them like a bit of, a nice bit of understanding of what we're going to be working with. Now, I'm going to give everybody an example. Thank you, Tandolwetu. I'm just going to mute you for a second. All right. So when we talk about natural numbers, guys, we're talking about counting numbers. So your natural numbers will start from 1, 2, 3, ... Okay, all the way until infinity. Okay, those are your natural numbers. Now, your whole numbers are just natural numbers plus one more. It's going to be all of your natural numbers plus 0. We're just going to add 0 and then 1 and then 2 and then 3 and ... Okay, now when it comes to integers, what we're going to get for integers is we're going to get natural numbers plus whole numbers plus integers. So integers has natural numbers and whole numbers in it. The only difference with integers is that we're going to get our negative numbers. So we'll have -3, all of those numbers in that direction, -2, -1, and then we're going to include our whole numbers. So I'm going to include 0 for our whole numbers, and then I'm going to include my natural numbers. So 1, 2, 3, all of the numbers going in both directions. Okay, so what you guys will notice is what I'm doing is I'm now taking natural numbers and I'm adding all of the natural numbers plus the whole numbers. And if I then take my integers, I'm going to take my natural numbers plus my whole numbers plus my integers. So when we get to rational numbers, who can tell me what are we going to do when we get to rational numbers? If I want to express my natural numbers, how would I put that together? Think about how I've added the whole numbers and the integers. Anybody want to venture? Remember, you can unmute whenever you're ready. Anybody got an idea? Think about what ma'am has just done. What is the next one going to look like? Buikanyo, I can see you speaking and I feel like you've got the right answer for me. And even if it's not the right answer, it's not a big deal, but I do hear a voice. Whose voice is it? No, Lutando, are you there, my sweetie? Ooh, okay. I think Nolutando's having a bit of a problem. Okay. It's no problem, Wikanyo. If you don't feel like unmuting and speaking, that's fine as well. Okay, we're going to take it at your guys' pace. It's not a big deal. Okay, watch what I'm going to do. I'm going to say that rational numbers are natural numbers plus whole numbers plus integers plus rational numbers. Now, what our rational numbers are going to do is they're just going to include fractions, because a rational number is actually a fraction. So things like 1/3, 2/5, 6/7. Those are our rational numbers, right? Now, I want to ask this question and I want to see who can answer it. Why can I say that the number 2 is also a rational number? Why can I say that the number 2 is also a fraction? Why can I say that? Think about it. How do we express fractions, really? How can we express 2 so that we look at it as a rational number? You can type in the chat if you don't feel like unmuting, or you can just unmute and give me an answer. What do we think, guys? Yes, yes, sir.
And I think you can say, you can write 2 as a fraction by saying 2/1.
100% correct. I can write it as 2/1. Does that change the value of the number, Tanurati?
No, ma'am, I don't think so.
No, it doesn't, because 2 divided by 1 is just 2. So basically, we're looking at the same number. Well done. But Tanurati, don't mute. Do not mute. I want to ask you, if we now have to look at, oh, and I'll be lying, we're going to skip irrational, because rational and irrational numbers don't go together. Okay, if I now had to express real numbers, think about what ma'am has been doing up here. How would I express real numbers? What do you think we would say?
Real numbers.
I'm going to start at natural numbers. So real numbers are natural numbers, and then
Whole numbers.
Plus. Good, keep going.
Plus integers.
Plus. Good.
Rational.
Plus real numbers. Okay.
Yes,
all of them put together make up real numbers. Okay, well done, Tanuletu. Oh, you're on a roll today, dude. Keep going. Excellent. Okay, so all of them kind of come together. The only difference is that irrational numbers are numbers that we cannot write as a fraction. Okay, numbers that cannot be written as a fraction. For example, pi. Okay, we've all seen what pi is. I think in school, when we were still, a little bit younger, they used to say that pi was 3,14. But we know for a fact that pi doesn't stop at 3,14, does it? No, it doesn't. It goes on forever and ever. It's like 3,14,159,268, da 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 da, and it keeps going on and on and on and on and on for forever. And there's no pattern. I can't really find a pattern to the numbers. They're in a weird order that we can't find. So that makes pi irrational. If any of you have a calculator next to you, I want you to type into your calculator the square root of 5 and check what your calculator does. Okay. All right. It also gives us a weird number with many, many decimals that should go on forever. It's just that our calculator screen is too small, right? So if we put in the square root of 5 and we click SD, we're going to get 2,236,067,977. Do we see any order there? Is there any order there? No, there's no order, which means the square root of 5 is also irrational because we don't know how we're going to write it as a fraction. It doesn't count. Okay, we can't write it as something over something. All right, and that's how we can tell the difference between all of these numbers. All right. So rational numbers are numbers that we can write as a fraction. Irrational numbers are numbers that we can't write as a fraction. Okay. So those are the two things we need to remember. Now, this is actually what I teach my grade 8s and my grade 9s. So we're not actually going to be focusing on this that much, but we must understand it, because the older we get in grade 11, it's going to come up again. In matric, it's going to come up again. So we need to understand it very, very well. Okay, now, the two things that we're going to be focusing on in grade 10 are your integers. We're going to be focusing on your integers, and we're going to be focusing on your real numbers. Okay, those are the two that we're going to be focusing on today. All right. Okay, now I want to remind you guys that if you look at our integers, we've got 0. Oh, now I'm erasing things. I've got 0, I've got -1, I've got 1, I've got 2, I've got 3. Would it count as an integer? Would any number count as an integer if I said 1,6? Is 1,6 an integer? Look at the numbers I've got written over here. Does it count as any of those numbers? Yes or no? Okay, I'm going to give you a hint. The correct answer is no. Okay, it doesn't count. Okay, because integers come from whole numbers, and whole numbers can't be your comma somethings. Our comma somethings only come in when we write fractions. So everything on this side of my number line must always be a whole number. So I can only get 2 or 5 or 7 or -6. I can't get -1,2. That is not an integer. Okay, it's not an integer at all. That is a rational number. So when we talk about integers, they must be positive or negative whole numbers. Okay, that's what we talk about, positive or negative whole numbers. That is our integers. All right, the other one we're going to be focusing on is our real numbers. Now, nice for us, real numbers just mean every single number. Every number. Okay, the natural numbers, the whole numbers, the integers, the rational numbers, the irrational numbers, all of them put together make up real numbers. The only thing that doesn't come up as a real number is going to be something like the square root of a negative number. Let's say, for instance, the square root of -4. Okay, this answer is non-real. If you punch this into your calculator, tell me what your calculator says. You can punch it in, you can type it in the chat. If you have like an old-ish, like a 2020 calculator somewhere there, good, it's going to give us an error. Exactly. It says maths error, right? Yeah, I can see Desmarie also going, yes, it gives us a maths error, because this is non-real. Okay, let's explain why this is non-real. If I asked you guys, I know that the square root of 4, what is the square root of 4? Do we know what the square root of 4 is? It should be easy enough, right? We should know this one. Which number multiplied by itself twice is going to give us 4? That's it, Buikanyo. I see you. You said 2. Beautiful. That's it. 2. Right. Now, if I had to work my way backwards, if I now had to say 2 squared, 2 squared is going to give me +4. Correct. I see you beautifully. Well done, my darling. All right. Now, what happens if I say the -2 all squared? What do we find that answer to be? If I said -2 all squared, that's like -2 multiplied by itself twice. What's going to happen to the negatives? It's going to give us a +4. It's going to give us a +4. Do you see how if I had to do the square root of any of these numbers, my answer must come out positive. It must give me +4. So if I then go to my calculator and I add a negative, my calculator says error, because even if I multiply by a negative number, my answer comes out positive. Do we see that? Give me a thumbs up if you guys understand where this comes from. Are we all good? Beautiful, Bikanyo. Excellent. Desmarie, if you just want to give me a thumbs up on your, that's it, on your screen. Beautiful. Puseletso and Tanduletu, thank you so much, guys. Excellent. Elisa, I hope you're with us. Nolitando. Oh, Nolitando's still having issues. I hope she messages me because I'm not getting any message from her. All right, excellent. Let's jump into what we're actually going to do today because this was just the intro. All right. So we know that we're going to be dealing exclusively with integers and real numbers. Now, what we want to do is we need to learn how to express this on a number line. Okay. So when we express this on a number line, we're going to think of integers as the numbers that are whole. So if I want to look at an integer, can I put my integer there? Give me a yes or no. If your camera is on, you can give me a thumbs up or a thumbs down with your hands. Is this an integer? Is this an integer over here? Yes or no? Tandoluchi says no. Wikanyo says yes. What do we think? Okay. Desmarie, Puseletso, what do we think? Yes or no? Okay. I mean, if we think about this, Puseletso says yes. If we think about this, this is sitting in between -2 and -3. That means that my number over here is actually -2,5. What did we say about integers? Integers need to be what kind of numbers? Whole numbers, whole numbers. So Tandalwetu, you're on point. Yes, my dude, this is not an integer because an integer can only sit there. It can only be at -2 or -3 or -1. That's how my integers need to look on my number line. Okay, give me a thumbs up if you understand what ma'am is saying. Okay, I cannot include the space in between here because the space inside here is not an integer. Okay, so when I express integers on a number line, I can only put dots at the numbers themselves. I can put a dot there and a dot there and a dot there because everything in between doesn't count. It doesn't count. Your -2,4, that's it, correct, Desmarie. So your -2,4, even on the other side, let's say for instance, 3,3. 3,3 is not an integer. We cannot count it as an integer. All right, so let's talk about how we will represent integers on a number line. If I asked you guys to represent all the integers from -4 to 0, okay, what that tells me is I have to go to -4, put a dot there. Where else do I need to put a dot? Remember, from -4 to 0, where else would I need to put a dot? You can type your answer in the chat. If you want to unmute, go ahead and tell me. Where else? I want all of them from -4. So I've started at -4 and I'm going all the way to 0. What's that going to look like? Ah, beautiful, Tandalwetu, that's it. We need to put a dot at -1, put another dot at -2, put another dot at -1, oh, -3. I said -1. I meant -3. You guys know what I meant. Right, -3, -2, -1, and we need to include 0 because we're going from -4 to 0. And this is how we express our integers. Okay. Make sure that we're seeing the way ma'am has written it. Okay, it's very important that we draw it out in that way. All right, excellent stuff. Okay, so let's talk about if I wanted you to express all the real numbers. Do you guys remember what we said about real numbers? We said that real numbers are every number, right? So does that also include the number in between here? Yes or no? Yeah, I see you. I see Buikanyo's like, yes, I agree with Buikanyo. Who else? Do we all agree? Yes? Are we all okay with the idea that we have to include all of them? Good. So instead of drawing dots everywhere, because that's going to take us forever, it's going to take us forever to draw a dot there, a dot there, a dot there, a dot there. We're not going to express it like that. If we want to express all the real numbers between -4 and 0, we are going to go just above -4 and we're going to put a dot. And then we're going to go just above 0 and we're going to put a dot. And then we're going to join them with a line. And that line tells me to include everything here. Include, oh, and my spelling, guys, I'm a math teacher. Ne? Include everything. So if my English is not Englishing, guys, it's because I'm a math teacher. I don't know what to tell you. Okay. Include everything. That's what that line that connects them means. Okay, so I hope we're noticing the difference between integers when we express integers and when we express real numbers on a number line. Okay, I'm going to do a quick check-in. Okay, you can unmute quickly and say, yes, ma'am. Okay, or you can just give me a thumbs up on your video if you're feeling this, if you're understanding where ma'am is coming from. Are we all good? I feel like we're in a good space. Everybody's with me. Beautiful stuff. Amazing. Well done, well done, well done. Okay, now we need to get in how to actually write it. Okay, I know I'm saying I want all the real numbers between -4 and 0, but remember, guys, maths is a universal language. Okay, what that means is if you one day meet someone from China and they don't speak English, you should be able to still write maths and they should still be able to understand it. So maths is the same everywhere. Okay, so we are not really going to use letters. We're not going to use English. We're going to use math language. Okay, and the first one we're going to learn is called set builder notation. I'm going to move this down a little bit. We're going to learn set builder notation. Okay, so here's what we're going to do. And remember, guys, it's important for us to write it properly because this is a mathematical language. It's a language. Okay, I want to express that same thing that we did just now. I'm going to start by going curly brackets. I'm going to open curly brackets. And then I know that I'm looking for some number x. I don't know what that x is yet because my x can sit in between all of these numbers, right? I don't know what it is, some number x. But I want x to sit in between -4 and 0. But I also want x to be an integer. Remember, the Z stands for integer. Okay, so we need to write it like that. Okay, and the reason why we use x, the reason why we use the letter x is because in between -4 and 0, there's more than one number. Yes, there isn't just one number in between -4 and 0. So my answer could either be -4, or it could be -3, or it could be -2, or it could be -1, or it could be 0. So I can't write all of these numbers in that spot. I can't write all of them. So instead of writing out all the numbers that are in between there, we're going to express those numbers as x. Okay, give me a thumbs up if what ma'am has said makes sense. Are you guys with me? Yes? Okay, we need to remember this. Remember this. It's very important. Remember this, the way we've written it. Okay, so if I give you this, what this tells me is that either I now need to do what we did before. Put a dot at -4, put a dot at -3, at -2, at -1, and at 0. Okay, that's what that tells me. Okay, I'm going to see if we can do another one. I'm going to write another one on the screen, and I want you guys to tell me either in the chat or if you feel confident, you can unmute and tell me where I need to put my dots. Okay, I'm going to open this, and I'm going to go x, some number x. I don't know what that number is, but I want x to be greater or equal to 3. I also want x to be an element of the integer family. the integer group, right? So where would I start? At what number would I start? You can type this in the chat. Anybody got an idea? Which number are we going to start at? Give me a range of numbers. What numbers would we do? Yes, Puikanyo. Yes, my sweetie, you can unmute for me. Unmute. It's okay, my sweetie. Or maybe if you're feeling too shy and you don't want to unmute, you can do this with your fingers. Show me the numbers with your fingers and I will write them down. Okay? Don't stress. Good. All right. So Puikanyo says we can start at 3. And then where are we going from 3? 2. Ooh, remember? Have a look here. X must be bigger. X must be bigger than 3 because the crocodile mouth opens towards X. Ah, there we go. That's it. You've got it. 4, and then that's it. And then 5. Keep going. 6, beautiful. And then when we get here, we know we're going to keep going, right? And then 7, and then 8, and then 9. So what we can do is, that's it. And then 10. Yes, 100%. Yes. You must cook. Yes, they must see that you know what you're doing. 100%. So when we get here, we know that the numbers keep going. So I'm going to put an arrow like that. Okay. An arrow like that to show that my integers keep going. They're going to keep going forever and ever and ever. All right. So that's how we express integers on a number line when we've been given set builder notation. Okay. Remember, this type of notation that we're using here is called set builder notation. Set builder notation. All right. Okay. Bikanyo's finally unmuted. I would love to hear her beautiful voice if she dares to speak to me. It's all right, my sweetie. We've got the whole year together. Don't stress. Okay, whenever you're feeling ready, we can talk. All right, let's think about another one. Okay, I'm going to write down another set builder notation. Desmarie or maybe Puseleto, if you guys are feeling confident enough to do this one, I'm happy to either hear your voices or you can type in the chat for me or you can use your screen. All right, I'm going to say that I want X to be less than -1. Okay, but I want X to be an element of real numbers. I want it to be an element of real numbers. Now, I want you guys to remember that real numbers includes everything, including everything in between. It includes everything in between. Okay, and we're going to learn something new with this that I've just written on the screen. Okay, so anybody is welcome, but I really do want to hear from Desmarie and Puseleto. So if you guys are feeling confident, I'm happy to hear from you. If not, or if you don't know, you can just be like, oh, ma'am, I don't know. I don't know what's happened. Okay. Good. Puseleto says -1, 100%. Now, I want us to note something. Okay. Puseleto says we will start at -1, and she's 100% correct, right? But if you look at the other examples that we did, do you notice how ma'am keeps putting this little line at the bottom there? Do you see how there's a little line there? Right? So it's either less than or equal to, less than or equal to. Do you see how this one doesn't have a line at the bottom? It doesn't have a line. That means that we are going to start at -1, but we are not going to include it. So we're not going to color in the dot like we did with the others. Okay. In the other ones, because that was included, we had to color in the dot. But for this one, we don't color in the dot. So we're going to start at -1. And then we're going to move that way because X needs to be less than. Do you see how my arrow is smaller next to X, which means X must be less than -1, which means it has to be all the numbers in that direction. Okay, Puseleto, are you okay with this? I see you saying you can't see it. Just let me know. Are you okay with this? Okay. Everybody can give me a yes, ma'am, or a thumbs up. Are we okay with what ma'am has done here? Okay. All right, my sweetie, please just let me know how I can help. I'm happy to help in any way. Just, I need you to understand this is quite important. Okay. All right. Beautiful stuff, guys. Okay. Correct. Okay. Yeah, let's address this a little bit because even my grade 10s at my school get a little bit confused. If the sum looks like this, if it says x is greater than 5, do you see, we're going to treat this little sign here in the middle as almost like a crocodile mouth. Okay. Do you see when my crocodile mouth opens to? Do you see that my crocodile mouth opens towards x? Yes? That means that x must be every number bigger than 5. So my x must be 6 or 7 or 8. All of the numbers bigger than 5, right? But if my sign looks like that, the bigger number, my crocodile mouth is open towards 5. So that means that my x must be smaller than 5. So all my numbers 4, 3, 2, 1, 0, -1, and like that. That's it, you're correct. Okay, so we need to consider what that mouth is doing. Okay, are we okay with this? Excellent. Okay, so we're going to look at another one. Let's look at another example because I want us to get this right. Okay, remember, we're still doing set builder notation. We're still doing set builder notation. Here's the next example. I'm going to go squiggly brackets. I want some number x. We don't know what that number is because it could be a lot of different numbers, but I want x to be greater than -3, but greater than or equal to 2, and I want x to be a part of the real number family. Let's talk about what this will look like. Okay, where would we start? If we read this middle part, where would we start? At what number? That's it, you're correct. We would start at -3. But do you notice how it's less than or it's not equal to? Do you see how there's no equal to sign? Yes? So am I going to draw an open dot like that or a closed dot like that? Open or closed? What are we thinking? Closed, I think, but remember, we can only close it if it's also equal to. Okay. Desmarais says open, correct. It's going to be open. Okay, it's open because there's no sign underneath. Okay, for this one, we're going to put an open dot. So we're going to go to -3 and we're going to put an open dot, just like that. But when we go to 2, let's go to 2. What kind of dot are we going to draw at 2? Open or closed dot? That's it. We can just now seeing it, right? Because over here, they've put there or equals to. So at 2, we're going to put a closed dot like that, right? Excellent. We're going to put a closed dot like that. Now, it says that x is an element of real numbers. Does real numbers include everything in between here? Yes or no? Real numbers include what? What does real numbers include? Real numbers include every number. Correct. It includes every number. So does it count? Does all the numbers in between count? Do they count? Yes, they do. Of course they do, because they're part of real numbers. Good. Now, I want us to note here. Do you see how the mouth over here is opened towards 2? That means x must be less than 2. So all the numbers here will make up x is less than 2. But over here, it says that x needs to be greater than 3. So Can I draw my arrow that way for -3? For -3. Can I draw my arrow in that direction? No, I can't. No, because x needs to be greater than -3. My mouth opens towards x. Good. So I can't draw my arrow that way. I must draw my arrow this way. But because these two things are already going to meet, instead of drawing arrows, I'm just going to draw a line. I'm just going to draw a line and join them. Okay. Are we all good? I hope everybody's with me here. Loving to see it. Amazing stuff. Nicely done, Wikanyo. Well done, guys. All right, let's keep going. Okay, I'm going to then give you one more. If I have x, and x is in between 0, x, and 4. But x is an element of z. Z means integers. Now, if it has integers, can I draw a straight line like that? Does it include everything? Do integers include every number? No, they don't. No. No, they don't. So we know that we have to start at which number? Yes, that's it. Correct. At 0. Beautiful. We're going to start at 0. Okay. In fact, I'm lying. For integers, we need to draw it on the line. So I'm going to draw a dot at 0. Okay, I'm going to explain again, just as we're talking about this Tandulwe too. All right, so if we think about this, guys, I've drawn a dot at 0. Do you see how my sign over here has an equal to? It's greater than or equal to. There's an equal to there. So am I going to color this dot in or leave it open? Closed or open dot? Closed or open? Remember, it includes, it's or equal to. So as soon as we include it, closed or open dot? Who remembers? Hey, for this one, it's a closed. Yeah, not maybe, definitely closed. Because as soon as we see the line, remember guys, if there's a line underneath there, that line means or equal to. So as soon as we see that or equal to, we must close our dot. Okay, it must be closed. Okay, then we're going to go to 4. We're going to go to 4. Does 4 have an equal to over there? Does it have an or equal to? No, it doesn't. So closed or open dot? It must be, that's it, correct. It must be open because we didn't include it. That's it, Tandalwetu, do we see it? So we're going to go to 4 and we're going to put an open dot, right? But remember guys, x is in between 0 and 4. So because it's an integer, can I go ahead and draw a line like that? Does an integer include everything in between? Does an integer include that? No, it doesn't. It doesn't include any of those. So we need to go to each individual number and we must put a dot, right? Now, this one must be closed because that makes up part of x. X must be closed. And 2 must be closed. And 3 must be closed because those are the numbers that we can consider. 4 needs to stay open because we didn't include it. All right. Excellent. Okay, how are we feeling? You can tell me in the chat, are we okay with this? Like, ma'am, I get you. I feel confident, or I get you, ma'am, but I still need a bit more practice. Pusiletso says thumbs up. I'm glad. Excellent. Okay. Nice one, Tandolwetu. Thank you very much. I hope everybody's on the same page with me. Thank you, Desmarie. Well done. Okay. I'm hoping we're all okay. Not in this case, Buikanyo, because remember, if we join them, that means that we are working with real numbers. Remember, integers need to be whole numbers. We can't include this part here. Okay, so we're only just gonna draw dot, 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 dot. Okay, we can't join them. It doesn't include anything in between. Got me? Are we all good? Good, excellent. All right, so this is set builder notation, guys. Now, unfortunately for you guys at school, they're not going to help you with this. They're not going to help you with it. You need to remember how to write it. Okay, you need to remember how to write it. You must remember first we start with curly brackets, and then we put an X, and then a colon, and then the numbers, and then semicolon, and then X is an element of the. You must remember that whole thing. We're not going to help you. You must remember it yourself. Okay, so we must start getting used to writing this. Okay, this is set builder notation. I want us now to focus on interval notation, right? We're going to talk a bit about interval notation. Okay, now I want to preface this by saying that interval notation is for real numbers. Real numbers. Okay, just for real numbers. So whenever you see interval notation, it's because we are using real numbers. So if we're looking at real numbers, are we going to then go to our number line and draw dot, 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 dot? Does that make sense to do that for real numbers? No, it doesn't. I can see Desmarie going, no, it doesn't make sense. That's correct, Useletso. It doesn't. Because our real numbers must join. We must join them with a line. Most of the time it's a line. Sometimes it's an arrow. Okay. So here's what interval notation looks like, and here's what we need to remember. Okay. If in my interval notation I see square brackets, if I see somebody draw square brackets, that means that I must draw a closed dot. I must draw a closed dot. But if I see somebody using round brackets, that means I must draw a open dot. Okay, I want us to write that down because we need to remember this. It's going to be very important. Okay, so square brackets, closed dot, round brackets, open dot. Okay, and then I'm going to teach you guys how to write this. Okay. So remember, we're only working with real numbers, so we're going to have to draw dots. I mean, not dots, lines. We're going to draw lines. It's not integers where we have to draw dots. Okay, so we're going to go. I'm going to say to you guys that X is an element of. X is an element of. And then I'm going to draw square brackets. And I'm going to put -3. And then I'm going to put a colon like that, or a semicolon. And then I'm going to do that sign. What does that sign mean? Do we know what that sign means? That is it. Correct, Bikanyo. It is infinity. I can read lips. Very good at it. Okay, good. It's infinity. Now, because we don't know where infinity ends, I can't put square brackets around it. I can't include infinity. Because what number is infinity? We don't know. We don't know. So wherever we see infinity, we're just going to put round brackets. Okay, so if we read this that ma'am has written here, where are we going to start? We're going to start at -3. I'm going to go to -3, and my square brackets tells me what kind of dot do I need here, open or closed dot? Open. Good. I can see Desmarie go closed. Correct. It's a closed dot because I've got square brackets. So I'm going to put a dot and color it in, right? Now, we don't know where infinity goes to, right? Infinity goes on forever, ever, ever. So what we're going to do is we're just going to draw an arrow going in that direction to show us that this thing is going all the way to infinity, forever and ever and ever. Okay, give me a thumbs up. Are we okay with interval notation? Yes? Beautiful, well done. Okay, good. Let's try a different one. Thank you, Tandolwetu and Pusele, it's beautiful. Let's try a different one. Let's do this. I'm going to say that x is an element of round brackets, and I'm going to go negative infinity, and then I'm going to put 4, and then round brackets again. Okay, don't worry about the negative infinity because we don't know where negative infinity ends. I'm going to go to the number 4, and I'm going to draw a dot. Is it going to be open or closed? Open or closed? That's it, correct. It is open. Beautiful. That's it, it's going to be open. Now, where does negative infinity go? Does it go to the positive side? No, nope, it can't go to the positive side. So negative infinity needs to go in the opposite direction, right? So we're gonna start at 4 and we're going to go that way, all the way to negative infinity. All right. And that is it. Guys, well done. You've just learned interval notation. Do you see how quickly that went? It was very quick. Right. But let's try one more. Let's try one more. I want us to try one more. I want us to do this. If x is an element of square brackets, -5 dot 3 round brackets. Okay. Where are we going to start? At what number? That's it, at -5. Yes, beautiful. Whew. You guys are just on fire today. Well done. That's it. We're going to start at -5. Closed or open dot? Closed or open dot? That's it, Puseleto. Closed. That's it. Yes, Tandulwetu. Well done. Closed. Okay, where are we going? How far are we going? To which number? Remember, we need to read this part. With -5 all the way until, that's it, Tandolwetu, all the way up until 3. Remember, there's no infinity there. So we can't go all the way to positive infinity because they haven't given us infinity in there. Okay, they haven't given us infinity. They're telling us to start at -5 and end at 3. But there's a round bracket. So we're going to go to 3, closed or open dot? Open, correct, open dot, that's it. So we're going to go there and put in open dot. And then we're going to take these two things and we're going to join them with a line. I'm sorry, my line isn't straight, but that's how we're going to join them. Right, and that's what we get there for interval notation. All right. Oh, guys, that is where today's lesson ends.